Hello everyone, welcome to Happy Chemistry. Let's begin today's lesson, Units of Measurements. In my last video, I talked about properties of matter. Some of these properties of matter are quantitative. That means these properties are expressed using numbers. For example, if I say measure 250 of sugar, is it meaningful? Can you measure 250 of sugar? No, you cannot, because you don't know if it is 250 grams, 250 kilograms, 250 pounds that you need to measure. Therefore, the numbers to be meaningful, the units of the measurement must be specified. A set of units used in measurements is called a metric system. There are several metric systems used globally. The internationally agreed standard metric system for scientific measurements is called International System of Units. Or, in other words, we call these units SI units. SI unit system has 7 special units. We call them base SI units. Now we will look at what are these SI base units and what is the importance of these 7 base units. Here I will give you the property, the standard SI unit, the dimension symbol, and the abbreviation used for the SI unit. The first base parameter is mass, which is denoted by capital M. Standard unit is kilogram, which is abbreviated by simple letters kg. Second parameter is length, which is denoted by capital L. Standard unit is meter, which is abbreviated by simple m. The third parameter is time, which is denoted by capital T. Standard unit is second, which is abbreviated by simple S. Fourth parameter is temperature, which is denoted by capital theta. Standard unit is Kelvin, which is abbreviated by capital K. Fifth parameter is amount of substance, which is denoted by capital N. Standard unit is mole, which is abbreviated by simple letters MOL. Sixth parameter is electric current, which is denoted by capital I. Standard unit is ampere, which is abbreviated by capital A. The seventh parameter is luminous intensity, which is denoted by capital J. Standard unit is candela, which is abbreviated by simple letters CD. The importance of the base SI units is all the other SI units can be derived from these base units. Now let's see how the unit derivation is done. For example, we will now consider speed. The definition of speed is the distance traveled per unit time. Now, how to derive the unit of speed? If we write an equation form, speed is equal to distance traveled divided by traveling time. Both of these are base parameters. The unit of distance traveled is meters. The unit of traveling time is seconds. If we consider these units in the same equation form, we get meters divided by seconds. That means unit of speed in meters per second. Let's now see how the units are derived for density. The definition of density is mass per unit volume. To derive the units of density, we need to write the definition in an equation form. The density is equal to mass divided by volume. The unit of mass is gram. The unit of volume is milliliters. If we consider these units in the same equation form, the units of density would be gram divided by milliliter. That means grams per milliliter. And 1 milliliter is equal to 1 cubic centimeter. Therefore, grams per milliliter can be expressed as grams per cubic centimeter. And all these units are base units. Let's now see some more unit derivations. Here we have several parameters that have their own SI units. However, all these units can be derived in terms of SI base units. For example, frequency. Frequency is measured by SI unit Hertz. The equation form of frequency is inverse of wave period. That means unit is per second, which is a base unit. Similarly, SI unit of electric charge is coulomb. The equation form is electric current multiplied by time. Both are base parameters. In terms of SI base units, coulomb is equal to ampere second. Let's now see pressure. The SI unit of pressure is Pascal. The equation form is force divided by area. Force has an SI unit Newton and can also be expressed in base SI unit as kilogram per meter per square second. This also can be expressed in terms of other SI units as newtons per square meter. All the SI units listed here, Hertz, Coulomb, Newton, Pascal, Joule, Volt, Farad and Ohms, can be expressed in terms of base SI units. Some of these can be expressed in other SI units too. Now let's look at another important aspect of units. For example, as we discussed, the standard SI unit for the base parameter length is meter. But what if we are measuring a very big length or a very small length? The reporting of the numbers will be really difficult. This is not practical. Therefore, to describe fractions or multiples of units, unit conversion is implemented. To indicate the unit conversion, the prefixes are used. Here, the prefixes are listed for fractions and multiples, and the example is given using meter. For example, 1000 meters is equal to 1 kilometer. The prefix for denoting 1000 is kilo. Similarly, for 10 to the power 15, peta, for 10 to the power 12, tera, for 10 to the power 9, giga, for 10 to the power 6, mega, for 10 to the power 3, kilo, for 10 to the power minus 1, deci, for 10 to the power minus 2, centi, for 10 to the power minus 3, milli, for 10 to the power minus 6, micro, for 10 to the power minus 9, nano, for 10 to the power minus 12, pico, for 10 to the power minus 15, femto prefixes are used. Now let's look at dimensional analysis, which is an important step in problem solving. In a problem, there are given units and the desired units. The information provided to solve the problem are provided with given units. The answer is requested with desired units. Therefore, the given units also should be converted to desired units. To do that, we should see how much given units are equal to how much desired units. We call this the conversion factor. If we multiply the given units by this conversion factor, we are now left with desired units. For example, 100 centimeters is equal to 1 meter. Then what is 258 centimeters in meters? Centimeters is the given unit. Meters is the desired unit. Conversion factor is 1 meter divided by 100 centimeter. When the desired measurement is 258 centimeter is multiplied by the conversion factor, the units cancel off and we are left with the desired unit. And the answer is 2.58 meters. This should be done throughout the problem to make sure that you get the correct units. In summary, today we talked about metric system, SI units, base SI units, derivation of units, unit conversion, and dimensional analysis. That's the end of today's lesson. Hope you liked the video. Give it a big thumbs up. Leave your comments and questions below. Subscribe to my channel. Turn on the notifications to be notified as soon as a new video is uploaded. Don't forget to follow me on Facebook and Twitter. Stay tuned. See you in my next lesson. Until then, happy chemistry. Bye bye.